Hi, welcome to the Explainer series for Quant. Here we'll be using very simple concepts and apply it to CAT level problems and solve them as easily as possible. In this session, we will look at moduluses, a concept which comes up very frequently in CAT, XAT and IIFT examinations. We would also look at some additional concepts in moduluses on solving two moduluses at the same time, all those type of questions, etc. I would suggest pause this video, look at the questions. The link is available in the description of this video. Once you've tried this on your own, then proceed with the rest of this session. Please do share this with your friends who are preparing for CAT and other MBA entrance examinations. You can like and follow us on Facebook as well as subscribe to our YouTube channel to get live event and notifications for all the updates regarding CAT and other MBA entrance examination. You can also look at our WhatsApp as well as Telegram lists. You can join over there and we will update you. We don't spam over there. If you want, you can enroll for our Quant and LRDI courses. These are the best and the most comprehensive courses available in the market. The modulus function as such is defined in a pretty straightforward manner. Modulus basically gives you the real value, the algebraic value of the expression, right? It will always return a positive or a non-negative number, right? So if you put x is equal to minus 5 into the modulus function, right, it will give you 5. However, if you put 0, that will still give you 0. If you put 5 in this, it will return 5, right? So if you plot the graph of y is equal to mod x, it will look something like this, right? Based on this, we have a few properties of modulus, right? These are very handy in solving questions, right? These are some algebraic properties, right? So we already discussed this, right? If you add two numbers, right, the combined modulus will always be lesser than the modulus of two numbers individually. Now, when will it be equal? They will be equal when both the numbers are of the same sign. So if both x and y are positive, then mod of x plus y will be equal to modulus of x plus modulus of y. Or if both of them are negative, in that case also modulus of x plus y will be equal to modulus of x plus modulus of y. If two of them are of different signs, right, you will get a value which is lesser. You can prove this pretty easily taking a few examples. Let's see. You have x, y. You have to check for modulus of x plus y and modulus of x plus modulus of y, right? So let's take two negative numbers, minus 0.1 and minus 0.3, right? Modulus of x plus y will be modulus of minus 0.1 minus 0.3, that's minus 0.4, that will be 0.4, right? Modulus of x will be 0.1, modulus of y will be 0.3. When you add them, you will get 0.4. So they will become equal. On the other hand, if you take two values of opposite numbers, say let's say 5 and minus 2, 5 plus minus 2 will be modulus of 3, which will be 3. And in this case, it will be modulus of 5 plus modulus of minus 2, which is 2, which will give you 7. So this is less than that. So to repeat, this will be equal when both of them are of the same signs. Now, again, modulus of x into y will be same as the product of individual moduluses. Division will be the same. And if you raise a modulus to an even power, it will be same as the original value raised to the even power, right? Because even powers destroy the sign, positive or negative sign. So let's use these in practice. The first one is from XAT 2018. It says, if the product of modulus of x minus 1 and modulus of y plus 3 lies between 2 and 5, both inclusive, x and y are both negative integers, find the possible combinations of x and y. Right? Now there is a lower bound which is non-zero, right? So you cannot make this 0. So you'll have to exclude the values where it becomes 0. Now modulus of x minus 1 will become 0 when x is equal to 1. Right? When x is equal to 1, modulus of x minus 1 will become 0. But since x is a negative number, it's a negative integer, it cannot reach 1. So we are safe with x. With y, when y is equal to minus 3, modulus of y plus 3 will become 0, right? So that scenario has to be ruled out, right? Further, x minus 1 will always keep on increasing because it's in the negative range, right? So you'll have, when you put x is equal to -1, -2, -3, -4. You cannot put any value beyond -4, right? Because when you put x is equal to -5, right? X is equal to -5, right? Modulus of x minus 1 will become 6. 6 into any natural number, right? This will return a natural number, right? Will always be more than 5. It will be out of this bound. So these are the 4 possible values of x, right? Let's look at y, right? So x minus 1 will become 2, 3, 4, and 5. Now with y, there are multiple scenarios possible. Right, y can go from -1, -2. You cannot put -3. You can put -4, -5, -6, -7. You can go all the way till -8. If you put -9, modulus of y plus 3 will become 6. Again, the same problem as earlier, right? So in this case, it will return 2, this will return 1, this will return 1, this will return 2, 3, 4, and 5. Now, the problem is not just these values, the product of these numbers, right? 2 into 2 will be 4, satisfies. 2 into 3 will be 6, does not satisfy, does not satisfy, does not satisfy. With 1, all the values will satisfy. 2, 3, 4, 5 are all possible. Again, with this one also 2, 3, 4, 5, all are possible. With this 2, only 2 into 2 will satisfy, right? That's 4. None of the other values will satisfy. With 3, 4, and 5, 3 into 2 will be 6, 3 into 3 will be 9, 3 into 4 will be 12, 3 into 5 will be 15. None of them will be satisfied. Same with 4, same with 5. Right? So these are the values, possible values are 1 plus 8, 9, 9 plus 1, 10. 10 possible combinations are there. Right? None of the other values will satisfy. In an exam situation, about 2.5, 3 minutes, it's not as easy as it seems. You need to be careful about a couple of things. One is the modulus symbol, and the second thing is you need to look at the combination of the products, not the individual values. The second question basically uses the properties of modulus almost directly. It says if x square plus y square is equal to 0.1 and modulus of x minus y is equal to 0.2, then what is the value of mod x plus mod y? It's from a pretty old CAT paper, right? Let's see. Now, I don't know x minus y exactly. It can be 0.2 or minus 0.2. But modulus of x minus y whole square will be 0.2 square. That's for sure, right? That will be 0.04, right? Let's expand this. Now, we know if you take a even power, right, it will destroy the sign. So I can directly write this as x minus y whole square will be equal to 0.04. Expand x minus y whole square, that will be x square plus y square minus 2xy is equal to 0.04. Now this value is equal to 0.1. So you get 2 times xy is equal to 0.06, or we know xy is equal to 0.03. Right, now I need to find the value of modulus of x plus modulus of y. Again, we'll apply the same trick again. Now modulus of x plus modulus of y whole square, right, will be equal to modulus of x square plus modulus of y whole square plus 2 times modulus of x into modulus of y. Now, applying this relation, modulus of x into modulus of y will be 2 times modulus of xy. Modulus of x whole square will be x square. Modulus of y whole square will be y square, right? We know all these values. What are these values? X square plus y square is equal to 0.1. 2 times xy will be equal to 0.06. 1.1 plus 0.06 will be 0.16, right? This is the value of modulus of x plus modulus of y whole square. Take the square root, you'll get 0.4. So modulus of x plus modulus of y will be equal to 0.4. Option B is your correct choice. Straight application of the properties of moduluses with some algebraic properties. Job done under 2 minutes. Question number 3, it's from a recent CAT paper. It says, what is the product of the distinct roots of this? So we'll have to find all possible roots and multiply them. Right? Let's see what this is. Right? So we'll have to use wavy curve sort of scenario for this. Right? How will we factorize this? I can factorize it as x minus 3 into x plus 2. Right? Modulus should be equal to x plus 2. Right? If you were to plot this, the main points will be minus 2 and 3. Between minus 2 and 3, right, the expression will return a negative number. Beyond this, the curve will open like this. Right? The curve will open like this. Right? So beyond minus 2 and 3, it will return a negative value. Beyond that, outside of this, it will return a positive number. Right? So if this is positive, then either x is more than or equal to 3 or x is less than or equal to minus 2. Right? So in this range, it will be positive. Right? In that case, when I expand this, this will be same as this. So we'll get x minus 3 into x plus 2 equals x plus 2. Right? Or if I rewrite, it will be x minus 3 into x plus 2 minus x plus 2 equals 0. Again, if I factorize this, this will be x plus 2 into x minus 3 minus 1, that will be x minus 4 equals 0. So the value of x will be either minus 2 or 4. Both of them lie in this criteria. Minus 2 is fine, it will return 0, and 4, it will be positive, right, which basically makes the modulus the correct one. Right? Let's look at the case where x lies between minus 2 and 3. If x lies between minus 2 and 3, right, this will be a negative value. So this side, right hand side will be negative. So you'll get x minus 3 into x plus 2 will be equal to minus of x plus 2. Again, following the same process, you will get x plus 2 into x minus 3. This will return plus 1 is equal to 0. So you'll get x plus 2 into x minus 2 will be equal to 0. Right? So x will be minus 2 or plus 2. Right? So there are actually there are 3 possible values: 4, minus 2 and plus 2. Minus 2 is repeated in both the cases. Right? So these are the 3 solutions. What are the 3 roots? Minus 2, 4 and plus 2. What is the product of these two? 4 into 2 is 8. 8 into minus 2 will be minus 16. Option D is your correct choice. If you're a little careful while opening the modulus symbol, can be solved in about 2.5 minutes time. Now, another type of question which people fret about a lot is when you have addition of multiple moduluses or manipulation of multiple moduluses. The easiest way to resolve this is understand how the curve will function. Right? When you have odd number of moduluses, right? When you have odd number of moduluses, like in this case 3 or in this case 5, right? There will be a lowest value of this curve, right? So this will be the lowest value of this curve. This will be the lowest value of this curve, right? And where will the lowest value happen? At the midpoint of the the middle value or the median of the 3 significant points. What are the significant points? Minus 5, minus 2, and 1. So the median is minus 2, right? So this will be the lowest value. And in this case, the median will be minus 3, minus 2, 1, 2, 3. So 1 will be the significant point. So this is the value of this curve, right? You can use the color coding to figure out which curve is which, right? In case of even number of terms, there will be this flat shape where through that entire range, right, it will be a constant value, right? It will be a constant value over there, right? So again, the constant value will be in between the two middle values, because there are even number of terms at the two middle values, it will be the case, right? So the middle values here are minus 2 and 1. So between minus 2 and 1, right? This curve will have the minimum value, and in this case, the two middle values are 1 and -1, right? It will have a flat bottom like this. Once you can visualize a curve like this, then basically the rest of two questions in this exercise can be solved pretty easily. The fourth question is from IIFT 2011. Again, it says, if x satisfies this inequality, then what is the range for x? Right? Now, we know there are three terms, right? So it will have a minimum value at one point, like we discussed, right? So, what will be the minimum point? The major points are 1, 2, and 3, right? Those are the significant points, are 1, 2, and 3. So, the curve will go something like this, right? Almost like Batman's wings, right? Inverted Batman's wings. So, you'll have 1, 2, and 3. Right, now we know where to find the parts. Now the minimum value will be at x is equal to 2. If you put x is equal to 2 here, this will become 0, this will become 1, this will become 1. 1 plus 1 will be equal to 2, will not be greater than or equal to 6. So anything which contains 2 as a range should be eliminated. So option A is out. Right, what happens at 1? At x is equal to 1, this will become 0, this will become 1, this will become 2. 0 plus 1 plus 2 will be equal to 3. Right, so x is equal to 1 is also out. Right, what happens at x is equal to 3? At x is equal to 3, right, at x is equal to 3, this will become 0, this will become 1, this will become 2. Right, so again this is 3. So even x is equal to 3 will be out. Option C is out. Now, what happens at x is equal to 0? At x is equal to 0, the value will be 1 plus 2 plus 3, which is 6. And lesser than this value, it will keep on increasing. Right? It will keep on increasing. So x less than 0 is fine. We can verify for x more than 4. At 4, the reverse will happen. It's a symmetrical sort of a curve. If you put x is equal to 4, right, this will give you 3. This will give you 2, this will give you 1, which is 6. So beyond 4 and beyond, it will be higher than or equal to 6. Option B is your correct choice. Again, you don't need to do all this. The moment you visualize this curve, the question can be solved much, much faster than what I've tried. I've just tried to put the values and explain it to you as much as possible. In an exam situation, max 1.5 to 2 minutes to solve this. And the last one, this is the sum of the possible values of x in the equation x plus 7 plus x minus 8 is equal to 16 is how much? Right? This is a direct application of this property. Right? We know that there is going to be a flat, there are two values. So there is going to be a flat value between x is equal to minus 7 and x is equal to 8. Between x is equal to minus 7 and 8, it will have a flat value, and after that it will increase. It will be like an inverted tub. It will be like a tub, right? What will be the value here? Put any value of the expression here. Put any value here. Let's put x is equal to 0. If you put x is equal to 0, you will get 7 plus 8. That will be equal to 15. Right? 0 lies in this range. So all these values will be equal to 15. You can verify if you put x is equal to 5. 5 lies in this range. If you put x is equal to 5, this will be 7 plus 5 will be 12. Plus 5 minus 8 is minus 3. Modulus of minus 3 will be 3. This is also will be equal to 15. So any value from minus 7 to 8 will return 15. Right? So your answer is going to be out of this range. Right? So you want 16. All these values are equal to 15. Now, there will be two distinct solutions. Now, that is not the question. You need to find all the values of the curve where it is equal to 16. Right? So, for it to be equal to 16, right, either it has to be more than 8 or it has to be less than minus 7. If you put value of less than minus 7, right, if you put value of minus 7, if you take x is less than minus 7, right, both these values will be negative. So you'll have minus of x plus 7 plus minus of x minus 8 should be equal to 16. Or in other words, x plus 7 plus x minus 8 should be equal to minus 16, right? If you rewrite this, you'll get 2x equals, this will be minus 1, so minus 1, so it'll be equal to minus 15, so x should be equal to minus 7.5, right? And when x is more than 8, both of them will return positive value, so x plus 7 plus x minus 8 should be equal to 16, or 2x should be equal to 17, x should be 8.5. Again, satisfies this criteria. X is more than 8. This also satisfies this criteria. X is less than minus 7. Sum of the possible values will be 8.5 minus 7.5, which is equal to 1. So these can be solved in, again, 2.5 minutes in an exam situation. For a XAT question, that's very, very precious. As you can see, moduluses are not very difficult. Some very commonsensical measures, if you know the basic properties, you can actually solve these questions very easily. Modulus are questions which people face a lot of problem with. People fret about it a lot. There are like multiple moduluses, modulus of a modulus, and all those things. Those questions usually come up only in mocks. You hardly see them in the CAT examination. Even if you see them in the CAT examination, you always have either a graph given to you, or you have the range of options which is given to you, right? Use those options, use that range, use that graph to solve them. Moduluses, if you apply the basic principles, can be solved in a pretty quick manner. It's a very scoring area in the examination. Usually you get 1 or 2 questions in a CAT examination, roughly around the same in a XAT examination as well. That completes this particular session. If you liked it, please do share it with your friends who are preparing for CAT and other MBA entrance examination. Please do subscribe to our YouTube channel as well as follow our Facebook page. The links for our course are available on the description to this video. Till we meet again the next time, goodbye and all the best.